Hello everyone, this is your junior high school math teacher, and in this video I'm going to discuss a lesson in trigonometry, which is the application of solving right triangles. Particularly when it comes to bearings and courses. Now, in some applications of trigonometry, especially in navigation, the bearing of a point Q from an observer P is the positive angle the ray from P through Q makes with a north-south line through P. This one. Okay? Okay, so I have here 4 figures. Then, in the figures shown above, theta is the bearing from P to Q. I think we are referring to figure A. Okay, this one right here. Theta is the bearing. When we say bearing, it is the angular direction from point P to Q. And 180 degrees plus theta is the bearing from Q to P. I think this one. Sometimes the bearing is specified as being measured east or west from north or south. For example, the bearing from P to Q is 60 degrees. This one right here. Okay? Particularly east of north. This one. Okay? So our reference here is the north to south line, no? Then, or that is 60 degrees east of north. Okay? Now, the bearing from P to R is 30 degrees, which is west of north. This one, P to R. 30 degrees west in reference of north. Now, the bearing from P to T is 45 degrees west of south. This one. From P to T. 45 degrees west of south. The bearing from P to U, this one, from P to U, is what? 15 degrees east of south. Okay? Next. Let us have some example. Now, 2 ships leave a port at the same time. Ship A sails on a course of 15 degrees east of north at 24 knots. When you say knots, it is the word that is shortened for nautical miles. Now, while ship B sails on a course of 105 degrees east of north at 7 knots or 7 nautical miles. Now, what is being asked from this problem? Okay, so we are going to find the following. The distance between the ships after 1 hour. Next, the bearing from ship A to ship B after an hour. And the bearing from ship B to ship A after an hour. So for our solution, we have these 2 figures. So in order for us to answer the first problem, this one, we need to illustrate. So this is the illustration. Okay? For number 2, this is how we illustrate the situation. And for the third one, ito naman yon, no? Yan. Now, let us solve each one of them. Okay, so let us have this one. Okay, so this is the figure. Again, 2 ships leave a port at the same time. Maybe that is from point C. Ship A sails on a course of 15 degrees east of north. So this is the north-south line. This is our reference. And from the starting point, which is point C, ship A goes to this direction with a course or bearing of 15 degrees east of north. Yeah. Covering a distance, okay, of 7 knots, no? Okay. Then ship B going this way. Okay, this is 24 knots, the nautical mile. And this one right here, this is ship B sailing on this direction with a bearing of 105 degrees east of north, covering a distance of 7 nautical miles. So what is being asked? The distance between the two ships after an hour. So how far those two ships from one another after covering their respective distance. So this is what we've been looking for. As you can see from the figure, there is a right triangle formed. So basically, by Pythagorean theorem, we can compute for the length of the hypotenuse. And whatever that length is, the unit is nm also, or what we call nautical miles, or in short, it's knots. Okay? So, by Pythagorean theorem, that is c squared is equal to a squared plus b squared. So, by plugging in the value of a and b, so that is 24 squared plus 7 squared, so that is 576 plus 49, it's 625. So that is actually c squared. And from that resulting equation, we can get the square root of both sides, so that the required distance is actually the square root of 625, or that is 25 knots or 25 nautical miles. So this is the answer. Okay? Next. The second problem, the bearing from ship A to ship B after an hour. So how do we analyze the problem? So at point A, let us project a north-south line and let us extend this. Okay. Then we solve. To solve the bearing from ship B, the bearing of ship B from A, we have to solve for theta or alpha. So that is tangent alpha is equal to B over A. So that is alpha is equal to the arc tangent of B over A. So that is 7 over 24. Or that is equal to 16 degrees. Okay. From figure number 2, this one, the supplement of alpha is 64. Okay, so this one. 164 rather. So, but the course from ship A to ship A is 15 degrees. This one, no? Yeah. Thus, the bearing of ship A from ship B is what? 164 plus 15, that is 179. This one. Okay, going this way. From ship A, ship A from ship B. Okay, 179. Okay, next. The third one, the bearing from ship B to ship A. So this is the illustration. So we have already determined this angular measure. So what do we do? The bearing from ship A, or from the bearing of ship A from ship B. So that is what? 180 plus 179. Yan. So that is 359. Okay?